Okay, today is November 11th, 2011. We're on page 226 of your textbook, so make sure you have that out. We're going to go over prerequisite skills for this chapter, and then we're going to start the very first lesson. So we got quite a bit to go over today. First thing we're going to do is we're going to talk about our key ideas. There are three major ideas we need to look at: linear equations, quadratic equations, and exponential equations. We need to review the stuff we know about that from the previous years. So the first thing we're going to cover is we're going to go over a linear equation. So with a linear equation, we'll be dealing with a straight line. So we're going to put a straight line up here. Some of the ideas we need to remember from a linear equation. The main one is we need to know the slope of a line. We have to remember how to calculate the slope of a line. So, okay, so our formula for slope of a line, y2 minus y1 equals x2 minus x1. So what we're going to do is we're going to take a look at the line we have here, and we're going to plot two of the points and then plug them into that formula. So we're going to quickly take a look. I have this point here, which is at 4 and 7. And I have another point here, which is at 8 and 9. So I'm going to call this my first coordinate, and this one my second coordinate. So if that's my first coordinate, this will be my x1 and my y1. This will be my x2 and y2. So we're going to plug those into the equation. y2 is 9. Subtract y1, which is 7. Divided by x2, which is 8. Subtract x1, which is 4. We end up with 2 over 4, which is a half, or 0.5. So the slope of this line, let's fix that half. The slope of this line is 1 over 2, or 0.5. So that's the constant rate of change. It's important to remember that term, that this line, because it's linear and straight, has a constant rate of change. So remember also that slope discusses rise over run. It's also equal to rise over run. So what this is saying, that every time we go up 2 increments on the x-axis, so that's our run, every time we go over 2, we go up 1 increment on the y-axis. It's the same rate of change. Also with linear equations, one other thing we want to recap. Let's zoom for a second. We want to make sure that we know about their vertical intercept, which is also known as the y-intercept. Okay? So, the equation of a linear equation is written like this. Y equals mx, m was our slope, plus b. M was our slope, b is our y-intercept. Now, in the textbook, because we're mostly dealing with analyzing graphs, they may also call this the vertical intercept. It helps describe the y-intercept. So our y-intercept with the line we had here, or our vertical intercept, would be where?
Would be there, 0 and 5.
0 and 5. The reason they call it a vertical intercept is because our y-axis is a vertical line. So it's either your y-intercept or vertical intercept. Okay? Oops. The next thing we're going to cover is quadratic equations. So a quadratic equation has a graph quadratic equation has a graph that's called a parabola.
Parabola, you remember this? You need to know.
Okay, so what's going to be important for our graphing in this chapter is you guys will need to be able to point out the vertex of a parabola, its X-intercepts, and Y-intercepts. So, the vertex of this parabola, I'm going to say is right here. I've moved it just a little. But it's going to be at 5 and 7. What's important about a vertex of a parabola is it's the highest or lowest point. So it's also known as the max or minimum of that graph. It also runs right through the middle. It's also called the axis of symmetry. The x value, so in this case our x value is 5. So the axis of symmetry, or AOS, is x is equal to 5. Okay? So the vertex has quite a lot of information we need to know about. A couple other things we need to know are the X-intercepts, which they may call horizontal intercepts. X-intercepts tell us when the x value in the equation is equal to 0. So a lot of times if you're doing profit or a plane's taking off and landing, these are very important points on the graph. So if this was a company's profit, this equation here was representing their profit, this would tell us that they have to sell 2 of a product. As they sell up, their max profit would be when they sell 5. And then if they sell more than 8 of something, it costs them too much to make and they start to lose profit. Okay? So it's important we can recognize our X-intercepts. We have 2 of them here. One of them is at 2 and 0. The other one's at 8 and 0 for the graph we've made. And finally, and I actually didn't extend this graph far enough. Okay? We also need to know a Y-intercept, which we know, again, they may also call vertical. C-E-P-T. There you go. A vertical intercept. A vertical intercept is when y is at 0. Or sorry, not y is at 0. When x is at 0. Okay? In other words, that may be the starting point. So again, if this was a company's profit and x was the item they're selling, when they have sold nothing, so if the company is just running and selling nothing at all, their profit right here would be negative, let's say it's in the thousands, negative $9,000 if they're selling nothing. The y-intercept's important for interpreting a graph. I'm going to fix this a little. Should be negative 9. Okay? So, when this company starts out, if they're just running a business, so that means they have a building, they're running the electricity, paying employees, but they're not selling anything, this company would be losing $9,000. They need to get up to 2 to be at a break-even point. They need to sell at least 2 objects, maybe it's cars or houses, in order to be breaking even. Then if they're selling 5, they're at max profit, and anything over 8, they start to lose money again. These are all very important. The max and min of a parabola, X-intercepts, and Y-intercepts. Last major graph we need to know for this chapter is we need to know about exponential growth and decay. I'm not the best at drawing these. So, our first graph I've drawn here, would that be exponential growth or decay? Growth, very good. So this represents exponential growth. As we go farther and farther to the right, we're constantly increasing, getting higher and higher. The one in green. Oh, actually, yeah, you're right.
Sorry, I like the beard first.
Thank you. Okay, so again, we've drawn two graphs, exponential growth and exponential decay. There's a couple instances where we're going to need to use these. Again, some of the major things you need to know is you're going to have to find the You're going to have to find the vertical or y-intercept. Of these graphs. Now, I have a question for you. What is the vertical or y-intercept for most of these graphs?
The one that goes to 1.
It's usually at 1. Okay? For most of these graphs, if we have an equation that looks something like this, okay, that's when our variable, our exponent is a variable. Whenever x is 0, we'll be looking at 1. Now we're going to look at some graphs that are a little different from this, but for the most part, we're going through 1. Okay? Exponential growth, when going from left to right, we're constantly getting higher and higher. And decay is the opposite. We're always getting closer and closer to the x-axis without eventually touching it. The other thing I want you guys to know is we need to be able to calculate growth and decay factors. So I'm going to put a formula.